So let's talk about how we can use the Riemann Zeta function to prove that there are infinitely many primes. If you're anything like me, this is interesting, and if this is interesting to you, maybe like and subscribe. And yeah, with that glorious intro out of the way, let's just get right into the video. So, in order to prove that there are infinitely many primes using this thing, there are two things that we're going to need to prove. The first one is that there is a link between the Riemann Zeta function and prime numbers, and I'm going to get to that in just a sec. The other thing is that we have to show that for a value of 1, S diverges. S doesn't diverge, the zeta value of 1 diverges. Alright, but let's get into the link between this guy and prime numbers. So what I'm going to do is I'm just going to start by just writing this out as a series. I'm just going to write this guy out. So zeta of S, and I'm just going to write it in a bit of a less condensed way. So we'll get 1 over 2 to the S, plus 1 over 3 to the S, plus 1 over 4 to the S, 1 over 5, and so on. Now what I'm going to do is I'm going to times this function by 1 over 2 to the S times zeta of S. And so this is going to look like this. Just go term by term. And again, I'm just going to write out 5 terms. And that's a good enough representation of this thing. Now what I'm going to do is I'm going to just find the difference between these, and what you're going to notice is that all the terms which have a factor of 2 in them are going to end up disappearing. So I'm going to write this as zeta of S times by 1 minus 1 over 2 to the S is going to equal 1 plus 1 over 3 to the S plus 1 over 5 to the S. Add on 1 over 7 to the S and 1 over 9 to the S, and so on. Don't really matter. Right, and I'm just gonna get rid of some of this stuff and make a bit of room for myself. Let's delete that and let's drag this guy up here. Alright, and now we're gonna just do the same thing. So apart from, I'm gonna take this entire thing, so with this factor of 1 minus 1 over 2s as well, and I'm going to times it by 1 over 3 to the S. So if I can just copy and paste this, save myself a bit of time. Alright, so 1 over 3 to the S times by all this is going to be 1 over 3 to the S. This term here, 1 over 9 to the S. Add on 1 over 15. Add 1 over 21 to the S, and 27, and so on. And now what we're going to do is just same as before, we're going to subtract these, so we're going to get zeta of S times 1 minus 1 over 2 to the S times 1 minus 1 over 3 to the S. And what we're going to see is this time is that any term that has a factor of 3 in it is also going to get, well, taken out. So we're going to end up with 1 plus, well, the 3 is going to cancel with this 3, or 1 over 3 to the S. I feel like I've said that enough. It feels like a weird way of repeating myself. So we're going to get 1 over 5 to the S, 1 over 7 to the S is going to be unaffected, but this 9 here is going to get affected by this 9 here. So it's going to cancel out to 0. And we're going to have 1 over 11, 1 over 13, and so on. And just every other number that doesn't have a factor of 3 in it, or 2 in it. And what you'll notice is that if you keep on repeating this process for all prime numbers, then everything's going to end up cancelling, and you're just going to be left with 1 on the right hand side. So that is to say that zeta of S times by 1 minus 1 over 2 to the S times 1 minus 1 over 3 to the S times 1 minus 1 over 5 to the s, and why not, I'll write in one more, and this entire product is just going to equal to 1. In other words, zeta of s is equal to product over p, where p is a prime number, of 1 minus 1 over p to the s, all to the negative 1 as well, because we're dividing out. Alright, so that is the link between the zeta function and prime numbers. And I'm just gonna, actually, let's make some room. Okay, so you'll remember at the start of the video I said that there's also another thing that we need to show, and that is that zeta of 1 diverges. And this is actually a really simple proof, and what I've done is, I'm just gonna, if I can copy this in here. Yeah, so this is just from the Wikipedia. So what it is you just, this is from the Wikipedia of the harmonic series is what it's called, which is just zeta of 1. And you just compare it term by term to this other sequence, and you'll see that it's bigger than that other sequence. And so yeah, if you have zeta of s equals 1 diverges, then that means there's infinitely many primes, because if there was finitely many primes, then this would give you a finite number. And so that's just a real quick and easy way to do it.